Greetings to you. In this lesson, we want to build another motor control circuit and show you the discussion of PIDs on the oscilloscope so that you can see how you can control the meter without learning the Chinese circuit. And easily use this circuit in robotics and replace or integrate this circuit with a microcontroller. Let's see how we should do this. Well, as you can see here, and you are definitely familiar with this circuit, a motor control circuit, we're creating a PD bloom based on the IC 5 and 5 is. As you said in the previous lesson, you can use a microcontroller instead of the IC 5 and 5, which will also be done in this lesson. Well, as usual, I put a motor here and put the IC 5 and 5, and I also created a circuit related to the duty cycle or frequency, which is based on. This is what you were saying here, that in the software I came to 5 and 5, I put the frequency on the base kilo. I put the base kilohertz, the diode, the sucker, I am in the dam. That is, the motor with the sort of belt to the wheel. And well, I told you about the discussion of the hash doctrine in this matter in the previous session, how it is, and so I came here and implemented the same circuit. Now, in this circuit, in accordance with the explanations that I gave earlier, I have a transistor, which is actually the driver of our motor, and it is turned on so that there is no more pressure, and I control the motor directly. And so the transistor, as you say, receives its signal from the IC. Now let's go into the simulation to see how our medicine actually works. Well, as you can see, here the circuit is implemented in the same way as explained in the software. And in order not to take up any more time for a video, they didn't film the assembly, so I've included the exact same circuit here. And you can easily see that the IC is placed in the middle, and the 5 and 5 are in the middle, then the same transistor that was in the circuit. It is installed here, and the rest of my connection is exactly the same schematic that you saw, and I have also provided that schematic with this tutorial. The download link is at the bottom of the video distribution section. This is our circuit, and now what we have to do is connect these legs to the ground, and here is a wire that is connected to the base of the transistor like this, which actually sends a frequency of the IC to the base and the base to circulate this motor that is here, and the connections of the motor are also schematic. Well, I want to explain the schematic here because you saw it on the soft surface of the leash. Now this time what we want to do is come with an oscilloscope that I made myself, and I made it with flour in this. Let's give up on this circuit so that in addition to the fact that the circuit has now completed its work and is turning the motor, we can also observe its waveform on the oscilloscope. Now, if you want to know how to make this oscilloscope, we have put a tutorial on YouTube that tells you how to make this oscilloscope. We taught you that you can watch the link to this tutorial here and here. Of course, I have the link to this tutorial at the bottom of the distribution section of this video so that you can have this oscilloscope for yourself. We use this stylus. And since it is with Arduino, I will connect the USB cable to the Arduino RAM like this and put it here. Well, this oscilloscope, but every other oscilloscope has two probes, right? We have to send Moj to the oscilloscope to see it on the oscilloscope. Here, the wire is all the way to the negative of the circuit. The circuit is actually a wave generator. The red wire, which is our red probe, and this pulse wire is going to connect to. I also connect our oscilloscope to the IC pulse generator base, which is the 3rd and 5th pins, and our probe is connected, as we see here. Then I connect the power to the power supply. Here the red probe, the 12-volt power is supplied to the motor, and at the same time it supplies the IC, and my black probe, which is our negative, which I connected here. And in this way, our power supply is connected, so after I have connected the power supply, I turn on the power supply. And as we are happy, the motor will immediately start to spin because the AC is holding the pulse. And what is there is that you can see the pulse or waveform here, and in the oscilloscope, which this is exactly the pulse or frequency that is being generated by the IC, and it is generating it. If I come to polarize the pulse wire of the transistor that comes from the IC, see that the motor is turned on and the waveform changes a notch. Now, why do we still have the waveform? Because this is actually the prop in the oscilloscope waveform. I connected directly to the IC pin, and here is the connection wire for it. Well, you can see that our waveform looks like this from the diagram. And again, if I connect this signal to the transistor, to the base pin of the transistor, the motor starts to rotate, and in this way I have designed a simple motor driver here, and this is exactly the same circuit that you have made with our circuit, and it is working. You can see the waveform. And if it wasn't like the pass was in the state you're looking for, as you can see here, you can easily do the weapons on the circuit, for example, on this circuit 5 and 5 by changing the resistors and capacitors. We can change the pulse shape and make a sound. For example, we can lower the diode circuit, cut it right down, turn it on, whatever it needs. So we probably did that you can easily make this driver, make a modular motherboard for it. You can even mount it on a 1000-segment board and make your own connections. Until the future, we will have everything we need and we will do it well on the Real board. So this is it. But as I promised, we will also drive this circuit using a programmable IC. That is, we will make it a 5-way and 5-way and replace it with a microcontroller because as mentioned, we can use a microcontroller. I will cut the circuit. I will remove the red line so that it does not show us anything anymore because it is already connected to the microcontroller. So you can control the speed of the motor by giving it a program and change it. This is a very good feature that the microcontroller has because, for example, all the tours that if we want to change the 5 and 5 diode T-sucker, I have to build a circuit that first connect its potential. Really, we have to remove the resistors. Let's say its accuracy is not as good as a microcontroller. But in microcontrollers, you can very easily give the exact pulse that you want of the motor, even using a digital key, and learn its face, and even observe the face of the motor on the LCD. These are also the things that I want to teach you in the next 2 sessions. I will use a microcontroller, and what will our micro be? This is the oscilloscope, because in this oscilloscope, we have put a feature in its short, which is a signal generator or wave generator. We use our own generator for this whole circuit, and this time instead of the 5 and 5 from this microcontroller, which is ARD and Eno Nano, we give the pulse to the transistor to check the motor status. So let's continue to disassemble this circuit and make the 5 and 5 and bring the microcontroller to the place of this IC 5 and 5 and bang to see how it goes. Now what I do is I come and separate the whole circuit this board. We will make the motor okay. I separate this again and completely remove all the wires. This time we don't need this negative wire because we want to get the pulse from the microcontroller itself. So these capacitors. I connect a resistor to the base of our transistor to prevent the transistor from overheating and draw too much current from the micro that does not allow our microcontroller to burn out like this. Since we are using a 13-2-7 transistor, the base of the collector is the base of the collector. I will tell you what we do here. We apply the power supply to one of the input and motor terminals and connect the other wire of the motor to the collector terminal of the transistor. We prepare this jumper wire. Everyone uses the red jumper wire. From this jumper wire, I connect the pulse to the transistor through the emitter terminal of the transistor and the negative of the circuit. The power comes from here. It enters the motor. From the motor is scratched. It goes to the collector of the transistor. It is closed. And from the emitter of the transistor to the negative, and the transistor in the middle is left to the driver circuit. So now when we go to the same circuit, the motor does not turn. Why? Because the transistor does not receive any pulse from its base leg. And I'm the one who gives the pulse. It starts the motor to rotate. Now to see what pulse our circuit gives our oscilloscope, I am using the oscilloscope's pulse here, and I am showing it on its display so that you can see the pulse in the output. This is exactly the pulse that our oscilloscope is currently producing. I'm calibrating it a little to see it better. Look at what a regular and precise pulse it produces. If you compare this with the IC pulse of the 5 and 5 that has a little noise, you will see why we insist on using microcontrollers to give pulses, and we will do this in a small robot. If you look closely, the pulse is very regular. And clean, you can see it is very precise. If I explain your potential more, you will see that we have very minute pulses. So what do? We will cut this pulse from here and give it to our transistor. I told Mosin to connect the pulse to the transistor. Here the motor will start to rotate, as you can see. You can see that the transistor has done the drive and the motor has started to move. And now if I press the button, the motor stops again. Now imagine that we have changed the code, or it's general for the motor and microcontroller, and increased or decreased the speed. This is what we are going to do in the next step. And in the next session, we're going to teach you how to adjust the motor speed and display the motor speed on the LCD. That is, we will build this circuit in such a way that first we will see the character LCD of the motor speed. In addition, we will add 2 buttons to it so that by pressing one button, for example, the speed increases, and by pressing another button, the speed decreases. This is what we will save for the next session because we do not want the videos to be too long. So I hope that this session was useful for you. Now we have another step to move. We have moved forward with the robots, and you have also gained a basic familiarity with the microcontroller circuit, which of course we have a lot of work to do, and we will discuss the method of writing codes, and we will have changes and controls and all the possibilities, even if we add sensors and the robot itself decides based on the sensors which one to act. We will have all these things, and this session was the beginning of these things. So until the next session, God bless you.